Hello my dear students, this is Akash HD and welcome to the ASD physics classes students. I hope so you all are doing really great. So students, in this video we are going to learn about the accuracy, precision and error in a measurement. Very easy topic. Let's start the video and let's learn all these things. Okay students, so let's see here. So under the topic accuracy, precision and error in a measurement, let's see first some introduction. So see here. To understand a physical quantity completely, okay, we should measure it accurately, definitely, is it? An accurate measurement of physical quantity plays a very important role in the world of science. Now, definitely, first, if we want that, now we should measure it very properly. Now, then only we can use it further and all that. Now, measurement is very, very important. Okay, great. Now, see here. First one, accuracy. What is the accuracy? Let's see. It is a measure of the closeness of the measured value to the true value of a quantity. That means the closeness between the measured value and the true value. Later we are going to learn that this true value is not directly coming from the sky somewhere. Okay, this true value is also taken by the arithmetic mean of the measured values. Okay, but as of now we are seeing the two values. One is the true value and one is the measured value. Now that closeness of these two values is called what? Accuracy. So say here, smaller the error in the measured value, greater is its accuracy. Definitely if the error is less, definitely the reading will be more accurate and all that. Is it, students? So I hope so this accuracy is the very clear closeness of the measured value to the true value of a quantity. If we want errors should be very small, then only accuracy will be very high. Okay, now if we talk about here one example, so see here, let true value of length of a rod, how much I have taken here, 2.24 centimeter. Now this is the true value as of now. Okay, we have got directly true value. Later we will learn how to get this true value also. Okay, now it is measured by 3 students by using a vernier calipers, and their measured values are following. Okay, so some 3 students are there, they are going to measure one by one by using the vernier calipers, and for the vernier calipers, what is the least count? 0.01 centimeter. Okay, we will see that. So say here, measured value by student 1 is how much here? 2.22 centimeter. Then measured value by student 2, how much here? 2.25 centimeter. And then measured value by student 3, how much is there? 2.28 centimeter. They all are which value, students here? This all are measured values. Okay, measured values. Okay, now if we see here error in measured value 1. So what is the error? Error is used with the measured value minus true value. Okay, so see here, please, here this is the 2.22 minus 2.24. How much error is there? Measured value minus true value. So it is coming here minus 0.02 centimeter. Correct? Similarly, if we see the second one, see here 2.25 minus again 2.24. How much it is coming here? It will come here 0.01 centimeter. Similarly, if we go for the third one, 2.28 minus again true value 2.24. So how much coming is there? Here it is coming here 0.04 centimeter. Okay, forget about the magnitude and all that. Now closeness can be from maybe from the less value or maybe from the more value. Okay, so this minus and all, no need to worry as of now. I'm just taking here the magnitude is there. Okay, so this is the 0.02 centimeter. Now I have just taken the mod. So kindly tell me here which value is the very small. You can see, students, this value is the very small. Okay, that means we can tell very well, this 2.25 centimeter is close to the 2.24 centimeter than other values. Okay, so if we talk about here which one is the most accurate reading, that means we can tell here this value is the most accurate is there. Okay, or we can tell higher accuracy is there. No? So see here, the closeness of the measured value to the true value, 2.25 centimeter is the mostly close to the 2.24 centimeter. So here most accurate. If we talk about the least accurate, this 2.28 centimeter is going to be the least accurate, because here you can see error is the more. Is it great? Next one, let's go to the precision here. Na? Precision. Let's see here. Precision. It is a measure of the closeness of the multiple measured values to each other, na closeness of the multiple measured values here. Okay, now see here. Precision is independent of accuracy. A measurement can be very precise but not accurate and vice versa. Okay, the thing is that high accuracy does not mean high precision. Similarly, low accuracy does not mean low precision. Both are independent from each other. We are going to learn by the example. So see here, under the example, let's see. Again, we have taken the example C. Let true value of length of a rod, again I have taken here how much? 2.24 centimeter. Now we are going to understand the precision basic meaning. Okay, so see. It is measured by 3 instruments. I will represent with S by using a meter scale, vernier calipers and a screw gauge. For meter scale, least count will be 0.1 centimeter. Vernier calipers least count will be 0.01 centimeter and screw gauge least count will be 0.001 centimeter. Then what is the least count? Very simple. A smallest measurement that can be taken by any apparatus accurately is called the least count. We will see. Okay, so see here, and their measured values are following. Okay, we are going to see next one, but again remember that here precision means what? Closeness of the multiple measured values. Okay, so see here. Now, can you see here first this very well? Is it? Great. Now see here, example. So see here, measured values by student 1 using a meter scale. These measured values are there. Now, student 1 has taken the 3 measurements, 2.1 centimeter, 2.2 centimeter and 2.3 centimeter. Similarly, measured values by student 2 using vernier calipers how much? 2.22, 2.25 and 2.28 centimeter. Similarly, measured values by student 3 using screw gauge how much here? 2.124, 2.126 and 2.125 centimeter. Okay, but here if I write here the true value, no? Then we can see here the true value. What is there? The true value we know very well, 2.24 centimeter. Okay, so if you will see here, no? Which measurement is very close to the 2.24 centimeter, you can see very well. This measured values of the vernier calipers is very close, very close. That means we can tell here measurements of very close. Now, so see, measurements of vernier calipers is most accurate. Most accurate now, because here even if you match the digits, see this is the 2.2, but here how much? This is the 2.2 is there, but here only 2.1 and here also 2.1 is there. Okay, that means definitely we can see here the measured values of the vernier calipers is the very close to the true value, so we can tell this is the most accurate. After that, if we talk about here the precision means what? The closeness of the multiple measured values to each other. So if you will observe that for the screw gauge, values are very close. Why? Because sometimes even we can't able to directly see also. So remember that here more digits after the decimal, that means more precision. What I'm telling that here, students, more digits after decimal. Okay, that means more precision, or we can tell high precision, more precision. By this only we can tell that here the measured values are close to each other. Okay, so here you can see here how many digits after decimal? 3. Here after decimal 2, here after decimal 1. That means which one is the most precise? We can tell here screw gauge readings are most precise. What is this? Most precise, but not most accurate. Okay, but not most accurate. Okay, so students kindly see here very well, is it? So kindly understand very well. They used to ask question in a MCQ and AR and all that. Precision and accuracy is independent from each other. Okay, here you can see even the vernier calipers readings are very accurate, but they are not precise. But screw gauge readings are very precise, but they are not accurate. Is it? Great. Next one, kindly see here the error. So see here what is the error. So under the error we can see here, see, error is the amount of uncertainty present in the measurement made with a measuring instrument. Now amount of uncertainty present is called the error. Okay, now see, it is the difference between the measured value and the true value of a quantity, as I have told you before also, is it? So if I write here the mathematically, so I can write here this mathematically error is given by what? Error is given by measured value minus true value. Okay, even before also we have seen that. Okay, so you have to remember that this formula, measured value minus true value. Is it? Great. No? So see here. Now we are going to see here the classification of the errors. Sometimes no, they may ask in a MCQ, AR and theoretically also. No? So kindly see the classification of errors. So see here. Errors may arise from different sources and are usually classified as follows here. Okay. So first one we are going to see here systematic error. Which error? Systematic error. So see here. These are the errors whose causes are known to us. Due to known causes, these errors can be minimized. Very, very important. Due to known causes, if we know the cause of the error, then only we can minimize it. Okay. They can be either positive or negative. Okay. These errors can be further classified into three categories follows. Now, so this systematic error is also three categories are there. But remember that one thing here, okay, these systematic errors are known to us and they can be minimized. They can be either positive or negative. Remember that question came in a previous years. Now, first one, instrumental error. Even the name is suggesting. What is this? These errors are due to imperfect design or erroneous manufacture of the apparatus. Okay, we are going to see erroneous manufacture of the apparatus or instrument. These errors can be reduced by using more accurate instruments. Now, because the causes are known to us, okay, so we will use the more accurate instrument and this error can be minimized. Okay. After that, what is there? See the second one, environmental error. So what is this here? These errors are due to changes in external environmental conditions such as temperature, pressure, humidity, dust, vibrations or magnetic and electrostatic fields. Okay, related to the environment, these all are the factors are there. Is it? Great. Now students, the third one, observational errors. Okay, so see, these errors arises due to improper setting of the apparatus or carelessness in taking observations. Okay, so this error will be committed by the person who is taking the readings. Okay, so systematic error is classified into the three ways. We can see here the observational error, environmental error, and the previous one was which one? Instrumental error. Okay, students, kindly remember this. Okay, next one, second kind of error is there. What? A random error. After a systematic error, a random error. So see here, even the name is suggesting what is the name is there. See, the errors which occur irregularly and at random in magnitude and direction are called random errors. Okay. Now see, the causes of random errors are not known. Systematic error known, but random error, even causes itself is not known. Okay. So see, hence it is not possible to remove them completely. Okay, because the causes are not known, so even we cannot remove them completely. Now see here, random errors can be reduced by, very, very important point, can be reduced by repeating the observations a large number of times, okay, and taking the arithmetic mean of all the observations. Okay, students, so kindly see very well. If we want to reduce the random errors, we have to take multiple readings, okay, and then we have to take the arithmetic mean. Is it? Great. Now see here, for the example, this question came in exam, I remember. For example, if the random error in the arithmetic mean of 100 observations is x, then the random error in the arithmetic mean of 500 observations will be how much here? X by 5. If we are taking 100 observations, if the error is the x, then if we are taking more observations, 500 observations, how much? X by 5. Similarly, if we take 1000 observations, just comment it. 1000 observations means how much? Comment it. Okay, great. Now the third one is, students, the least count errors. The least count errors. What is this? See, the smallest value that can measured by the measuring instruments accurately is called, students, it's least count here. Again, I'm telling, the smallest value that can be measured by the measuring instrument accurately is called its least count. Okay, see, all the readings or measured values are good only up to this value. Okay, so before also I have told you, like if we talk about the vernier scale, the least count is the 0.01 centimeter. So up to 0.01 centimeter minimum it can measure, but if you want to measure 0.00001 centimeter, na, it cannot give the accurate reading. Na? So minimum reading that can be measured accurately for vernier calipers, how much? 0.01 centimeter. Screw gauge 0.001 centimeter. Is it? Great. Now see, the least count error is the error associated with the resolution of the instrument. Even sometimes in the question, if they are telling the resolution also, so that time whatever is the least count is there, na, that only we will write here, na, because in this topic this thing is the very confusing. Sometimes at the place of precision they will put the error, at the place of resolution they will put the error, at the place of least count will put the error. Na. When you will solve multiple questions, then you can understand the question very easily, what is the demand of the question. See, for example, least count error of vernier calipers, how much? 0.01 centimeter, as I have told you very well. Similarly, least count error of screw gauge is how much here? 0.001 centimeter. Okay, let's take, for example, I am just telling you now, let's take any reading is taken by vernier calipers. Okay, and let's take here, if in case we are measuring here the some area, no? Under the combination of the errors we are going to see. So area of the rectangle, how much here? Length into breadth. So when I will write here the error expression, it will be how much here? Delta A by A is equal to L power 1. That means 1 into delta L by L plus 1 into delta B by B. So what I am coming to tell you, students, if in case in the question nothing is mentioned, so this delta L and delta B as reading is taken by the vernier calipers, this value automatically we have to take here 0.01 centimeter. Remember that. And if in case this measurement is taken by screw gauge, automatically have to take this delta L and delta B 0.001 centimeter. Okay. So if in case error is not given, we will take a least count as the error. Okay. Great. Next one, see, very easy. Now the very easy topic came. See, representation of the errors, but important because we have to use it in a combination of errors. So say here, let a physical quantity is measured n times and the measured values are A1, A2, A3, dot, 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 AN. Na? Because whenever the students are going in a lab, now actually have to measure the only the, let's take for example, length, but one student will measure, second student will measure, third student will measure, even one student will measure multiple times also. Okay. Why we are measuring multiple times? To reduce the errors. Is it? Great. Now see, the first one, mean value or true value. Like before I have told you, na, true value is not directly coming from the sky. That this true value is also the mean of the observational readings and all that. Na? This is not coming from the sky. Okay, so see here. It is the arithmetic mean of all the observations. Okay, so if I write here the mean value, a mean or true value. So what will happen right here? These observations are there and we will add them all. A1 plus A2 plus A3 plus whatever observations are there plus AN by N. Okay, so this will be the which value? This will be the mean value of the mean value or the true value. Is it? Mean value or the true value. Remember that here. Next one, if we talk about here the absolute error. So see here, the difference between measured value and the true value is called absolute error. Even before also I have told you that was absolute error. Now, the absolute error in the individual measured values are given by. Okay. So, if we talk about here the absolute error in the measurement one. So, delta A1 will be how much is there? We can write here A1 minus A mean. Now, measured value minus true value. Okay. Similarly, if I write here the delta A2, just kindly guess, sir. What will be there? A2 minus A mean. Is it? Similarly, if I write here the delta A3, what is this? A3 minus A mean. Okay. And after that the multiple depending upon the observations we can do is there. Okay. And if I write here the delta AN, no? Then what we can write here? AN minus A mean. And depending upon the values, please remember that here this can be positive or negative. Positive also possible, negative also possible. Okay, these values can be positive or negative. No need to worry about this. Positive or negative, any readings can come here because we have calculated the individual absolute errors. Okay. Now third one, what is there here? The third one is the mean absolute error. See here please. It is the arithmetic mean of the magnitude of individual absolute errors. I have told you before, maybe positive, maybe negative, but here we have to take only magnitude, that means all positive. So mean absolute error, we will always put in a mod delta A mean is equal to what we can write here, mod delta A1 plus mod delta A2 plus dot dot dot, only magnitude, mod delta AN, okay, mod delta AN by N, okay. And when you will do this, this will come anyhow positive. This one will come anyhow positive because we are taking here the magnitude, is it? Now the note, final result of measurement can be written as, okay. So whenever we have to write here the final result, remember that, very very important, A mean plus minus delta A mean. Now, can you remember that very well? In this way, plus minus is there. In this way, we will represent the measurement. Okay, great. See, this implies that measurement is likely to lie between, where to where? It is likely to lie between, see here please, A mean minus delta A mean to A mean plus delta A mean. Okay, this is the maximum range is there where this measurements can lie there. Now, but remember that here A mean plus minus delta mean is the very important. Okay, see here, great. Now let's see here please, relative or fractional error. It is the ratio of mean absolute error to the mean value. Okay, so if I write here, see here the fractional error or the relative error. Now fractional error. So the fractional error is given here. I will write here delta A mean by A mean, or we can tell here the true value. Don't think that okay this A mean and A mean cancel. No, okay, because delta A mean by A mean is there. Okay, great. Now the fifth one, percentage error, is it? So see here please, when relative error is multiplied by 100 is called what, students? Is called here the percentage error. Okay, so what will happen that here, kindly see here, if I want to write here the percentage error, now very easily, this percentage error means what? This fractional error, that means delta A mean by mean, we have to just multiply with the 100 and you will get here the percentage error. Okay, so kindly see here very well. We have seen all these terms, 5 terms are there, is it? These 5 terms are all are very important. Okay, so now students, after that we are going to see here this question, direct calculation based question is there now, but okay, anyhow we will just see that here. Even before itself I have told you the answer, so that just calculation is there. By using the formula you can check it. So see here, the refractive index of glass is found to have the values 1.49, 1.50, 1.52, 1.54 and 1.48. Calculate mean value of refractive index. Okay, it will come how much here? 1.505. But okay, how much it will come here? If I write here the first one, if I write here the n mean, na? Refractive index, I am using the term here n. Okay, otherwise it's better to use here mu. Okay, so what will come here? This mu mean is given by, just add all of them, mu1 plus mu2 plus mu3. How many readings are there? 1, 2, 3, 4, 5. Okay, similarly mu4 and mu5. Okay, by 5. 5 observations are there, 1, 2, 3, 4, 5. So when you will simplify this, how much it will come here? It will come here 1.505. Okay, but you can see here in the given readings after decimal, how many digits? 2 digits. So here we will simplify this is there. You can see very well. This 5 is there. No? This 5 is there. Which one? This 5 is the uncertain digit and preceding digit is the 0. Okay, so when we will simplify this, even we can write here, no? Let it be, this digit we have to see even or odd. 0 is neither even nor odd. Okay, so but by default we used to consider here the even only. So what will come here? 1.50 centimeter. So what will come here, students? 1.50 centimeter. Similarly, the second one, absolute error in each measurement. Absolute error in each measurement. So what is this here? See, if I write here the delta mu1, I will do one for you. Now measured value minus true value. Measured value how much? 1.49 minus true value 1.50. So what is coming here? Minus 0.01 centimeter. Is it? Minus 0.01 centimeter. Similarly, other values also you can calculate, no problem. I will just calculate delta mu5. So what will come here? See, 1.48 minus 1.50. So again, what will come here, students? It will come here minus 0.02 centimeter. Now, directly when you can tell here minus 0.01. Here what will come? Here 0 will come. Here what will come here? Plus 0.02. Here it will come plus 0.04, and here it came here minus 0.02 centimeter. Okay. Third one, what is there? Mean absolute error. How you will get the mean absolute here? We know very well. For the mean absolute error here, we have to write here. We have to add all of them. Is there? Na? Let's take for example here. See this mu1, delta mu1. What is this? Delta mu1. Okay. So see here, this delta mu1 plus mod delta mu2. Is it? You will just continue this here, plus mod delta mu5. Okay. And by 5. So when you will simplify this, how much it will come here? Like 0.01 mod plus 0.01, then plus 0.02, whatever all this individually is there. Na? You see, even I can write it for you. So see, here how much coming is there? 0.01 plus next one what is coming here? 1.50 and minus 1.50, 0. Next one 1.52 minus 1.50, 0.02. Plus here 1.54 minus 1.50, what will come here? 0.04. 0.04 plus again you can say here 0.02 by 5. Okay, so when you will simplify this, how much it will come here? Students, mean absolute error, you can see very well 0.02. Okay, after that what will happen that here? Fractional error. Fractional error means what? Delta mean by a mean. That means very easily you have to just write here 0.02 by 1.5. Okay, and you will just get it there. Okay, here unit should not be there. Okay, because the effective index, how centimeter will come here? Unitless. Now after that what will be there? Percentage error. Whatever this value came na, by doing delta mu mean by mu mean, just multiply with the handle. How much is coming here? Plus minus 1.32%. Okay, so students, all these things are there na, kindly see here very well na. Very easy is there na, there is nothing too much logics and all is there na. So we have just done it here, we have just applied the formula and all. Is it, students? So I hope so. This video you have understood very well, especially the representation of the error we have seen that. Now that is very, very important, and how to represent like a mean plus minus delta mean, that is the most important, because this thing we are going to use in a combination of errors. So students, I hope so. This video is very clear to you. Okay, keep studying, keep growing.